Hey everyone, and welcome to the video. Today I'll be showing you an example of how to contribute to an open source project. For our example, we're going to look at a contribution to the HLISA repository. HLISA is used as a replacement for the Selenium action chain in order to automate the browser with human-like interactions. I recently submitted an issue asking if we could add the feature to adjust the typing speed. Let's take a look at the issue I made. In the description of the issue, I tell the maintainers of the HLISA project what I want to add and why. I tell them I want to add the ability to scale the typing speed because I want to be able to emulate the interactions of multiple people with the browser, and different people have different typing speeds. As you can see, the developer approved of my suggested feature, so we can go ahead and add it. Let's open GitHub for desktop and create a new branch in our HLISA fork. After creating our branch, let's make sure our branch is up to date with the master of the HLISA repository. Let's look at some of HLISA's internal code to find the functionality that has to do with typing. One of the functions we encounter is the sendKeys function. Inside that function, we observe that self.action.pause is used to determine the delay between typing letters, words, or sentences. Inside the pause function, we see that a random positive number is generated from a normal distribution and that some delay keyword arguments are passed to it. Let's take a look at the constants.py file to see what these quarks are. Looking at this example of delay quarks, we see that the delay quarks contains a mean, a standard deviation, as well as a minimal. In order to add the functionality of scaling the typing speed, we need to be able to adjust the mean of these delay quarks. Let's create a function that scales the mean of one of these delay quarks with a given scaling value. Let's go to the utils.py file and add a scale delay quarks function. The function takes in a scaling value as well as the delay keyword arguments we want to scale. In order to scale them using our function, we return the same keyword arguments, except we multiply the mean with our scaling value. Now that we're done with our scaling function, let's look at where we should apply the scaling. Let's look at the sendKeys function. We add speed scaling as an argument to the function, and we ensure that every use of pause has the scaling function applied. We also make sure that we pass the speed scaling as an argument to every other typing or writing function that is called inside of sendKeys. In this case, write sentence. We also encounter the sendKeysToElement function, which calls upon sendKeys which we just adjusted. Let's add a speed scaling argument to this function as well and pass the speed scaling on to the sendKeys function that is called inside of it. Let's now adjust the write sentence, write word, and write character functions which are used in the sendKeys function. We add the speed scaling argument to each of these functions, and we ensure that each use of write word, write sentence, or write character receives the speed scaling value to scale its own pauses. Once each of these functions receives the speed scaling argument, we can apply our scaling functions to all of the pauses we encounter. Now that we've made all our changes, let's go back to the GitHub desktop app to see them. Looking at our changes, we see that we made a couple of mistakes, so let's adjust for those. We also dive further into the write character function and realize that all delays in the write character function have to do with how long a key is pressed down when we type a character. With our scaling, we don't want to influence how long a key is held down because this might accidentally write multiple characters while intending to write a single one. So we remove all cases where we pass the speed scaling as an argument to the write character function, and we remove the scaling from the pauses in the write character function. We look over our changes again to see that they're correct. We can now commit our changes to the branch in our fork. After pushing the changes, we can look at the official HLISA GitHub repository, and we see an alert for the fact that we made a push to our fork. Let's click on Create Pull Request to make a request to merge with the master branch of the HLISA repository. It is important that we describe our changes, and we also notify the developers on our thoughts of changing the delay in the write character function. Finally, it is important to refer to the issue that was created to request the typing speed feature. This way an alert is added to the issue, so everyone looking at the issue can see that a pull request has been made. And let's complete the pull request. Hopefully this example helped in showing you that you can contribute to any open source project. If so, please leave a like, and if you want to see more content like this, consider subscribing. Have a nice day.